Here we're asked to determine the cosine function of the graph below. So in this one, we are going to first find the k and the a values from the midline and then the maximum and minimum. So the k value here is always told exactly by the midline. I can see the center horizontal line here is at 2, so that means that my k value is at 2 as well. Then my a value, two things I have to look at for the a value. First of all, the distance between the midline and the maximum, and then also if it's going to be positive or negative. What I see here is that my cosine function looks like it's actually going to be starting at the minimum here and then coming back down to the minimum, meaning it's going to be negative. And I can see here that the distance between the midline and the maximum is just 1. So my a value is going to be negative 1. Next, I got to look for the h value, which the h value is going to be told by the starting point. I say in quotations here because I kind of make this up, but basically the starting point, again, like I said earlier, with a negative cosine function, we start at the minimum. So I'm going to look for a minimum value, and I'm going to call this my starting point. And normally that's going to start on the y-axis, but if it has an h value, it shifts it one way or the other. So in this case here, we see that as going to the left 0.5 units. So that tells me that h is negative 0.5, or if you want it as a fraction, negative 1/2. Last thing is we got to do the b value. The b value is always 2 pi over the period. And remember, the period is the distance between these exact same points, or where our graph repeats itself. So in this case here, it looks like our period is equal to 6. So my b value is just equal to 2 pi over 6, which simplifies to pi over 3. Now it's just a matter of plugging this back into our original transformation equation. We get y equals negative 1 cosine of pi over 3, x plus 1/2 because it is a negative h value, and then plus 2. And that is our final equation.